The existential threat of a nuclear conflict is no longer a Cold War memory. With 9 states armed with atomic bombs that are an average 20 to 30 times stronger than those dropped in the Second World War, the stakes are undeniably higher. Now, only 2 nuclear weapons have ever been used in warfare when the U.S. targeted the Japanese cities of Hiroshima and Nagasaki in August 1945. The 2 bombs, Little Boy and Fat Man, exploded with a combined destructive power of more than 30 kilotons of energy. Yet they pale in comparison to the weapons in modern nuclear arsenals. Despite the devastation and worldwide shock following the bombings of Japan, U.S. interest in such explosives persisted. Now, the B-83 is the highest-yield nuclear weapon in America's arsenal. It's 80 times more powerful than Little Boy, and 650 of them are in active service. The global nuclear arms race reached a climax with the test of Russia's Tsar Bomba, a hydrogen aerial bomb produced during the Soviet era and detonated in 1961. Its force, 3,333 times that of Little Boy. Now, the explosion was felt nearly 1,000 kilometers away. 6 decades after the Tsar Bomba was deployed, no single device has matched its destructive power. The would-be era of super bombs may now be unfamiliar, but their power, if they're to be used, cannot be underestimated. Now, being at a ground zero of such an explosion would result in immediate casualties. A radioactive fireball would vaporize anyone in the blast zone. The weapons used in Japan leveled the land for thousands of hectares and killed an estimated more than 200,000 people. As for survivors of a nuclear explosion, radiation exposure can cause burns or sickness days, weeks, or months later, and then even years afterwards. Developing cancer remains a lifelong risk. In the Second World War, atomic arsenals were not abundant or powerful enough to trigger the feared nuclear winter. But now they are. One study suggests that 5 billion people would die in a modern nuclear war, as it would lead to catastrophic disruptions in food supplies. Climate models show in the event of a nuclear conflict, average global temperatures could drop by up to 25 degrees Celsius. And sunlight blocking suits in the atmosphere could wilt crops around the world. 77 years since the atomic bombings of Hiroshima and Nagasaki, some fear the risk of a nuclear confrontation remains very real. The UK's National Security Advisor, Sir Stephen Lovegrove, says this risk has increased because of the breakdown of communications between the West, Russia, and China. And given the staggering cost of a great-power nuclear war, even a small chance of it occurring is enough to get the world to think long and hard about what could happen if nations go beyond the brink.
For more on the consequences of the nuclear war, let's speak to Owen Bryan-Toon. He's a professor of atmospheric and oceanic sciences and a fellow at the Laboratory for Atmospheric and Space Physics at the University of Colorado Boulder. Professor, as geopolitical tensions rise in nuclear-armed states, we know that scientists are modeling the global impact of a possible nuclear war. But before we get to the worst-case scenario, perhaps talk us through what would happen if, for example, something occurred at the Zaporizhzhia nuclear power plant in Ukraine.
Well, nuclear power plants are reservoirs of incredible amounts of radioactivity. So it's not just the core of the reactor that's got a lot of radioactivity, but there's usually stored waste around it, which has several times more radioactivity in it. So, for example, the Chernobyl nuclear accident, which is in Ukraine, the remains of, released an amount of radioactivity in the form of long-lived isotopes that was equal to all the 500 nuclear weapons tests that had occurred before 1963 in the atmosphere. So you certainly don't want to rupture nuclear power plants. They're incredible sources of long-lived radioisotopes and short-lived isotopes as well.
And Professor, if an all-out nuclear war breaks out between the U.S. and Russia, I mean, I understand that between them, each got about 4,000 strategic nuclear weapons. But help us paint a picture of the worst-case scenario. What would happen in the days and months following a nuclear detonation?
Well, we've looked at 2 kinds of scenarios here. One is a war between Pakistan and India involving a few hundred nuclear weapons of low yield. And we've also looked at a war between NATO and Russia involving around 2,000 nuclear weapons of higher yield. And so the Russian and the American weapons, there's about 2,000 that are actually deployed and could potentially be fired very quickly. And the other 2,000 you mentioned are in storage, and it'd take quite a while to bring those out. But even a small number of these weapons is incredibly dangerous. So Russia only has 200 cities with 100,000 people. The United States only has 300 cities with more than 100,000 people in them. So it doesn't take very many weapons to attack every city in the opposing country. So we, right now, with these 2,000 weapons, we can attack, or the US and Russia could attack, each city with more than 100,000 people in it with 8 nuclear weapons. This is ridiculous because one nuclear weapon is enough to destroy a city. So there's a vast amount of overkill in these weapons.
And could you help us understand, or if you could elaborate on the term nuclear winter, how it's caused and how far-reaching are the implications?
Right. So what happens in a nuclear explosion is there's a bright burst of light. It's like bringing a piece of the sun down to the ground. And that bright burst of light can start everything on fire. There's also a blast wave that comes out and knocks down buildings and ruptures gas lines and things like that, which can cause additional fires. So when you look at the debris around Hiroshima, it wasn't caused by the bomb blast. It was caused by a firestorm that released 1,000 times the energy of the bomb from burning everything in that city. So what concerns us as climate scientists is that all those fires are going to generate a gigantic amount of smoke. And that smoke will rise into the upper atmosphere and into the stratosphere where it never rains. We've actually seen this happen twice in the last couple of years from large fires in Australia and in British Columbia, where smoke from fires went into the stratosphere and they stayed there, the smoke, for a year, when it could be easily observed by satellites. But in the case of a nuclear conflict, we would have thousands of times more smoke than from these forest fires. And the smoke will absorb sunlight in the stratosphere and keep it from reaching the lower atmosphere where we live. So we think a war between NATO and Russia will reduce the amount of sunlight reaching the ground by about 80%. There'll be about 20% of the light left. And as a consequence, there would be rapid cooling at the Earth's surface. And so at mid-latitudes, for example, in the Ukraine and Iowa, which are major grain-growing regions, we think the temperatures would drop within a few weeks below freezing, and there wouldn't be a day in the next 2 years in which it wasn't below freezing. So it'd take a couple of years to get above freezing. This would totally eliminate agriculture at mid-latitudes, and it would cause problems even in countries at lower latitudes, depending on how they grow their crops and what crops they have. So we took the climate calculations that we have for this war between NATO and Russia. We looked at every country in the world to see how they would be affected. And basically what we found is that Russia would lose 98% of its population by the second year. The United States would lose about 96 or 97% of its population. China would lose about 98% of its population. Canada would lose 98% of its population. They all have it in common that they're relatively high latitude countries. It's already cool. They already have short growing seasons. Their agriculture would be eliminated. If you look at places like Indonesia and Thailand, they lose 50 to 75% of their population. And an important assumption in here is that transport stops, because whatever people find to grow, they keep because their populations are starving. So this would be very bad for a country like Singapore, which doesn't grow much food and it's totally dependent on food transport. So basically, probably no one would send any food to Singapore in a situation like this. They would keep it for themselves. We think that of about 6 billion people that were assumed in this model, that 5 billion would die within the second year, and things would continue to be bad for several more years.
All right, Professor, I'm afraid we have to leave it there for now, but thank you very much for your expertise. That was Owen Brian Toon, Professor at Atmospheric and Oceanic Sciences, and also the Fellow at the Laboratory for Atmospheric and Space Physics at the University of Colorado Boulder.